Welcome back. Ready for some more integration? We're going to continue on 6-6. We're going to look at the area between curves. But today we're going to take it off the x-axis. So we're going to move off the x-axis and we're going to go between actually two different functions. So maybe we have a function that looks like this. We'll call it f of x. And then maybe we have another g of x that comes in. I don't know, maybe something like this. And we'll label that g of x, I guess. And we want to give it some boundaries. Maybe we're going to go from A to B here. So maybe we're interested in this region in here and define the area of it. Well, how do I do that? Well, what I'm going to do is take the top curve here, the higher y values, just like we saw before in the previous lesson, and we're going to subtract off of it the bottom curve. And essentially what that's doing is if we were to take this graph, or these boundaries, all the way down, we would be finding this entire area for f of x, under f of x, and then we'd be subtracting off this bottom area of g of x. And that would give us the region that's between those two graphs. So our formula, we're going to go from A to B, our two boundary points, of the top curve minus the bottom curve. And we're doing it with respect to the x-axis, so it's going to be our dx. So remember, our variables are always going to be in x. We can take it with respect to y, which we will eventually, if we get to there, but not today. So you'll want your graphing calculator, unless you can graph these by hand, which you should be able to graph them with your Algebra 2 expertise in pre-calculus. We're going to go ahead, though, and throw them in the calculator and see what we got. So graphing 2x minus 1 for our first function. Our second function is going to be x squared minus 4. We're going to go ahead and graph that. I'm going to sketch it out here for us so we can kind of see a little bit more of what it's going to look like. So we should hopefully know that we come through negative 2, come down to 4 for our y-intercept, and come back up through 2 for that quadratic. And then 2x minus 1 is going to go through negative 1 here, kind of go up in this direction and come down like this. But we're only interested from 0 to 2. So our area, give me a different marker here, is going to be in this region here. So what we're going to do is, again, we're going to take that top curve minus the bottom curve. So in this region, which one has higher y values as we move across the x-axis? And that's going to be this linear function 2x minus 1. So I'm going to integrate from 0 to 2 of 2x minus 1 minus that bottom curve, that g of x, which is x squared minus 4. And it's in terms of x, so we have our dx at the end. What I would suggest that we do is go ahead and clean up this integrin before we start integrating. So we're going to go from 0 to 2. That cleanup is going to be negative x squared plus 2x. We're going to multiply it negative through as well. So we get a positive 4 minus 1 gives us a positive 3 dx. We can go now. This is a simple integration. We have negative x to the third over 3 plus 2x squared over 2 simplifies to x squared plus 3x from 0 to 2. We can go ahead and plug in our 2. So we have negative 8 thirds plus 4 plus 6 minus plugging in 0. Well, nicely, they all have x's in them, so it's going to 0 everything out. So we have minus 0. So now we've got negative 8 thirds plus 10. And negative 8 thirds plus 10 is going to give us 7 and 1/3 for that area. So that gives us the area between these two regions on this interval 0 to 2. Example 2 is going to be very similar. Here, f of x is going to be a linear function, just 1. So that's fairly boring. So here's our function 1. I will label it f of x. G of x is x squared plus 3. So x squared plus 3, that's 1. 3 is going to be up here. Again, quadratic. We're going from 1 to 3. So here's 1, here's 3 on our graph. So we're looking between these two regions. That's going to go up a little farther. So we're going to have a fairly large area, it looks like, going from 1 to 3. So we're going to integrate our boundaries. We're going from 1 to 3. Our top curve, again, has higher y values. It's going to be that g of x, or x squared plus 3. From that, we're going to subtract the bottom curve. In this case, that's f of x, which is just 1 dx. We can go ahead and simplify that integrin. From 1 to 3, we have x squared plus 2 dx. We can go ahead and now integrate x squared plus 2. That gives us x to the third over 3 plus 2x from 1 to 3. 3 to the third divided by 3 gives us 9 plus 6. From that, we're going to subtract 1/3 plus 2. So we have 9 plus 6 minus 1/3 minus 2. 9 plus 6 gives us 15, minus 2 gives us 13, minus 1/3 gives us 12 and 2/3. So that's going to give us our answer there. Again, that's the area between those two regions. I have just one more example. Example 3, we're going to throw some e's in there. Hey, we love our e's. So again, we're going to throw this into our calculator. X to the third minus the 5x squared plus 2. And we're going to throw in our wonderful e to the 2x. And graphing those. There's our cubic function. And there's going to be our exponential function. So looking here, we have this graph comes like this. And then e to the 2x is going to come in, come up, and go out like that. So we should see that we have a little overlap over here, but it's not on the interval that we're interested in. So we're really not interested in anything out here or out to the right. We're only interested between 2 and 4. So between 2 and 4, well, here's 2, and then here's 4. So it's very clear to me, as we look at this area, that our top curve, again, is still one function. Our bottom curve is the other function. So as we set this integration up, we're going from 2 to 4. Our top curve is e to the 2x. From that, we're going to subtract that bottom curve, or that cubic, x to the third minus 5x squared plus 2 dx. Not a lot of cleaning up to do with this one. So we can integrate from 2 to 4 of e to the 2x minus x to the third plus 5x squared minus 2 dx. So now if we think about this, we know the integration of x to the third, 5x squared, and 2. E to the 2x, if e was a single variable, we would know, or had a single variable as an exponent, we would know that integration. Since we don't, we're going to do a little u substitution. So we're going to break this up from 2 to 4 of e to the 2x. And to that, we're going to dx. And we're going to add to that the integration from 2 to 4 of negative x to the third plus 5x squared minus 2 dx. So now I've got two different integrations I can work with. I know the integration of all these parts over here. E to the 2x, I need to do a little bit of work to. I'm going to let u equal 2x. Du equals 2 dx. Can't use the 2, so I have a half du equals dx. So my integration now becomes, since these were x's, I'm going to change them. So now I'm going to go from 4 to 8 of 1/2 e to the u du, plus, and I'm just going to drop this integration down, 2 to 4 of negative x to the third plus 5x squared minus 2 dx. Now I know the integration of each of my parts. Now I'm going to go ahead and integrate all of my parts. So integration of 1/2 e to the u is 1/2 e to the u from 4 to 8. To that we're going to add. The integration of negative x to the third gives us negative x to the fourth over 4. 5x to the third over 3 minus 2x from 2 to 4. So now I can go ahead, plug in my 8, plug in my 4. Going to need a little bit of room here. So we have 1/2. Again, 1/2 is a constant being multiplied, so I can leave it to the outside. 1/2 of e to the 8th minus e to the 4th. To that, we're going to add, plug in our 4. So we get the negative of 4 to the 4th divided by 4 gives us negative 64. Plus, we got 64 times 5 gives us 320 thirds minus 8. And from that, we're going to subtract, plugging in 2. So we get 2 to the 4th, 16 divided by 4 gives us a negative 4. So that we're going to add 8 times 5 gives us a 40 thirds minus 4. And at this point, I would go ahead and throw it into the calculator. So we have 1/2 of the quantity of e to the 8th minus e to the 4th. We're going to end that quantity. And then we're going to subtract 64. We're going to add 320 thirds. We're going to subtract 8. We're going to add 4. And we're going to multiply that negative through. We're going to subtract 40 thirds. And then we're going to add 4 to that. And we're going to end up with a whopping 1,492.513 as our area. And that's going to give us the area between two graphs.